Now we'll see how the connections for an energy meter experiment where you measure the energy using a single phase energy meter is being made. This is your circuit diagram. This is very similar to your residential house wiring. We use an energy meter, and on the other side of the one part of the energy meter, on the load side, you have loads being connected, and on the switch side we have a phase and a neutral line. Like previously said, phase should definitely be connected to the first wire of your energy meter. Neutral should definitely be connected to the second wire of your energy meter. Exchanging these two wires will not work, make your experiment work properly. And we have a DPST switch that is not being used here because we use a direct switch here. And one more important thing to remember is that for an ammeter, it is being connected on the line of phase, from phase to switch 1, phase to wire 1. In between that you insert your ammeter here, and you insert your voltmeter in between phase and neutral. Therefore your ammeter will have one phase line, and the second wire will be given to switch wire 1, and your voltmeter will have one phase line and the other one will be given to neutral, and then your second wire will be connected to neutral. These are the three things that you're supposed to take care when you're doing this experiment. And here is how the connection is being made. Okay, on the other side of second side of this part of the energy meter, it is being already connected, so you need not make any connections here. And here we'll start off with the phase line. So we have the phase line here. So from phase line we have one wire being connected to one side of your voltmeter, and in this case you should switch on your voltmeter to the AC supply. And AC supply does not have a red and black color, both are black in color, so you can use either this one or this one. So either this could be phase or this could be phase. It's up to you to decide which is your phase line. Okay, so we have our phase line here. Phase line is connected to voltmeter, so this connection is done. Phase line is connected to voltmeter. Your phase line should also be connected to ammeter, so we tap it from here. We take a wire from here and we connect it to one part of your ammeter. So this connection is also now done. Other connection is ammeter is connected to the first wire. Other end of the ammeter wire will be connected to your energy meter's first wire. This is your energy meter's first wire. Okay, coming to your energy meter second wire, this second wire should be connected to neutral. So you have the wire here, and this wire is being connected to neutral. So basically this connection is now done. Also your second wire, your voltmeter's other side should be connected to neutral. So this is your voltmeter's other side. So this wire is also tapped here, and this is also now connected to neutral. Okay, so when this is done, you can switch on the experiment. You can switch on the experiment and work accordingly. The procedure of the experiment is that you switch it on. Okay, take your voltmeter reading, take your ammeter reading at zero load. You have to switch off all the loads here. At zero load you have to take the reading, and your energy meter will not rotate at that time. And after that you have to increase the load. You have to switch on two lights, and then your voltmeter reading will definitely be 220 to 230 volt. It will not change, but there will be some current flowing through because you have switched on two lights. There will be some current flowing through, so there will be some reading in your ammeter, and your energy meter will start to rotate very slowly. So we have a disc here, and there is a black marking there on the disc which is not visible here. Okay, when the black marking passes this center line, you start to take out your stopwatch and count the time required for this black line to make one revolution. And when one revolution is done, you note that time, multiply it by 10 and write it in the tabular column. And for taking your next set of readings, you will switch on two more loads, and then you take your voltmeter reading, your ammeter reading. Your energy meter will start to rotate quickly, and this time again you take your stopwatch and start it when it passes the center line, and when it finishes off one rotation, you stop it there, and you take the readings and do the necessary calculations here. So these will be your readings. Okay, your ammeter value will keep increasing when you increase your load, and then the time taken for one revolution, 10 revolution, will be noted down and will be multiplied by 10. Here it's being multiplied by 5, but you are supposed to multiply it by 10.